Hi, and welcome to Chapter 4. We're doing 4.1 Angles in Radian Measure. Our objective is use the concept and notation of functions to interpret and apply them in terms of their context. And the essential question is, what is the difference between radians and degrees, and when is it better to use the radians? So, we're going to go back a little bit and talk about angles. An angle is formed by two rays that have a common end point. One ray is called the initial side and the other is the terminal side. So an angle is in standard position if its vertex is at the origin of a rectangular coordinate system. So your endpoint is at your origin, or 0, 0. And its initial side lies along the x-axis. So in both these situations, your blue line, which happens to be your initial side, is on your x-axis. When we see an initial side and a terminal side in place, there are two kinds of rotations you can have. So positive angles are generally counterclockwise rotation. So angle alpha is positive, and negative angles are generally in clockwise position. So angle theta is negative. So your first example, this is your alpha angle, so it's going counterclockwise, and this is your negative angle, so it's clockwise, and it's your theta. An angle is a quadrantal angle if its terminal side lies on the x-axis or on the y-axis. So angle beta is an example of a quadrant angle. So just a refresher on measuring angles. An acute is less than 90, right is 90, obtuse is more than 90 but less than 180, and your straight angle is 180. So an angle whose vertex is at the center of a circle is a central angle, and the radian measure of any central angle of a circle is the length of the incepted arc divided by their circle's radius. So your radian measure of a central angle of a circle, you want to use the arc and your radius to find it. So definition of a radian: one radian is the measure of the central angle of a circle that intercepts an arc equal to the length of the radius. So you have your terminal side, which is your ray, and then your radian is your center. So consider an arc length S. So your arc length is your S, and your radius is R. So the measure of your central angle theta is theta equals your arc length divided by your radius. So you have central angle theta in a circle who of a radius 12 intercepts an arc of length 42 feet. What is the radian measure? So you know theta equals your arc length over your radius. So your arc length is 42 divided by your radius. That should be 3.5. So your radian measure is 3.5 radians. So you want to know conversion between degrees and radians. Using the basic relationship, pi radians is 180 degrees. So no matter what, pi radians is 180 degrees. So in order to convert from degrees to radians, you want pi radians divided by 180. And to convert from radians to degrees, you want to multiply radians by 180 degrees over pi radians. We're going to do a couple examples. So I would write down, to convert degrees to radians, multiply your degrees by pi radians over 180 degrees. And to convert radians to degrees, you want to multiply radians by 180 over pi radians. So if I have 60 degrees and I'm converting that into radians, you need to have 60 times your pi radians over 180 degrees. So I have 60 pi over 180. That should give you pi over 3 radians. So do the same thing with 270. 270 degrees times pi radians over 180 degrees. You should have 3 pi over 2 radians. So pause the video and try the next one on your own. You should end up with negative 5 pi over 3 radians. Now we're going to try it the opposite way. So in this case, we have to multiply our radians to get, so we have radian, we have pi over 4 radians times 180 degrees over pi radians. Oh, sorry. So in this case, your pi's cancel out, and you're left with 45 degrees. Let's try the next one. If you were to simplify this, you would end up with negative 240 degrees. So try the next one on your own, and then we'll go over it. So this one was a little different where you have pi in your denominator. In this case, you will plug in your 3.14 and estimate your answer. So make sure you complete the questions below and watch the next video, and the next time we're going to continue talking about angles.